All right. So right now, I am remotely connected to the microscope computer in the lab right now. And you can also do this, but we are, Enrique and I are still trying to find a way to connect this via Tailscale. But currently, I am using AnyDesk, right? But, you guys you're mostly in the lab, right? You have to like get into the lab to do everything you want to do physically, right? You don't have to like remotely connect to the computer.
Most of the time we can record if it's a microscope, we are just recording like our data from the microscope to the computer. And for the rest of the stuff, mostly we are doing the microscope like data set analysis here, I think. And it should be fine.
Yeah.
It's recorded by like in that room physically.
All right. So So in the document here, I said to collect the data, you have to save the experimental data in your designated directory, which is on the external hard drive, and it is named as this. So once you are connected to the computer in the lab, so this is the folder created for you. And inside this folder, we have every biologist name here, right? Ahmed, Nona, Rachel's on there. And right here, you have to like save your data sets in your designated folder. And everything that you are doing here is automatically synchronized into the, oh my God, what's this? Let me look the book, please. Look the book, please. I apologize. I seriously apologize. All right.
Oh, no
So
worries.
right here, everything inside here synchronized into the server computer. And I'm going to show you now. So now to connect it to the server computer, you just have to like double click this particular icon, right? And then you double click this. So whenever you want to like perform further analysis, whenever you want to use any other tool, which is not currently present on the microscopic computer, you have to like remotely connect to the server computer and do whatever you want to do. But the data that you need, the data set you need, everything is already synchronized. All you just need to do is move the data set into the designated folder, and then you continue working on the server computer. But this is done after you have tested everything you want to test using our tool, the ND2 analyzer tool, which I'm also going to like explain further. I might not be able to do much demo of that, but I'm going to like create a video demo. This is just because of my internet right now. All right. So yeah, we said yeah, only save experimental data that needs to be analyzed in the specific folder that we discussed here. So every other folder, every other thing that you are doing, every other data that is not related to this analysis and that you want to leave for long-term storage, right? You have to like connect your external hard drive and store them there. This is just for us to manage the space we have currently on the microscope computer because it's not enough. It's just a few space that we have there. And, it is connected to the external hard drive. And I think we just have like less than 3 TB or less than 2 TB. And we have to like manage it as much as possible. So, uh, yeah, I said it here for all data that is not related to your analysis, right? Strictly transfer them to your personal hard drive or keep, just to keep the whole thing organized, the storage organized. So also, you know, when you are creating your directory for your particular experiment, we have a naming convention for this, just so that it can help us. And it can also help you as well to keep track of every project or every experiment that you're working on. So this is just the naming convention, the experiment dates, and in this format, right? So I'm just going to quickly create a file now, and just so that I can see how the synchronization works. Then also you must always include a README file. This is also going to really help us to, it's going to serve as a guide for us to know how to improve on the application, the tool, just so that I can serve you better as well. So basically, the tool has some features that can help you, visualize and analyze the image that you are generating, the data sets for anything that you want, for morphology, for checking self-classification and also for self-segmentation as well. So the tool is good for all of that. And also for population analysis, the tool is good for that. So all right. I'm going to create a file now, and I'm going to name it this. It's just going to be a text file. And this is going to happen right inside here. All right. So I'm going to be creating it inside known as folder. Oh man. You know what? I don't want to delay you, but you understand what I'm trying to do here, right? So,
Yeah.
let me just create a quick folder here. Let me just name it this. Yeah. So as soon as the folder is created, I'm connected to the server computer. You know, I have done everything I want to do on my ND2 analyzer tool, and I've confirmed my data set, is what I want and is what I want to proceed with. Then I can come here and write on this desktop folder inside the server computer. Just double click here, and everything is synchronized already. Uh, Mona, again, sorry. You get the point. Sorry, the network is too bad.
Oh, no worries.
So
No.
synchronization is done already, right? And
Mm-hmm.
this is it. It is not saved yet, probably due to network. So the new folder is created, and it's supposed to be named when we named it, but I don't know what's
Yeah.
really happened. The network. Oh, okay. You can
Yeah,
see it has been created already. It's the network. Network is so
yeah,
terrible.
yeah, because you
All
had
right.
like a one new folder and like that.
Exactly. And it's synchronized. So everything that you're doing is automatically synchronized. So what you just need to do is get your data sets from the microscope, and then you test it on our ND2 analyzer tool. And I'm going to show you the tool right now. And I'm just doing a summary of everything in point one and two right now. So this is the tool, right? So I'm going to create a clickable application for you, which I've done already, but I've not just moved it into the microscope computer. This is it. You can see something like this. I had to create a logo for it. So you just need to click it, and it's just going to open, and then you can perform whatever you want to perform, right? But when I'm done updating the application, I'm going to do that on the microscope computer, so you don't have to like be running it the way we developers are running it. All right. So let me just quickly import something here and do a quick demo of this. So this is one data set I have been working with for testing purpose. So it's just a phase contrast uh, data set, and I'm just setting it to 20, and the position, let's say 2. All right. It doesn't have any fluorescence, so obviously this is not going to have any reading at all. It's just default, so it's not going to have any effect. So basically, what you want to do, right? What our tool right now can do, you can segment your data, right? So you can, be able to visualize the cells very well. You can be able to see each cells and at their position, separated from their background and from, you know, the is basically separated from their background and every other disturbing cells around. So you can be able to see it clearly. It's currently segmenting. This shouldn't take so much time. Just a little more minutes. And yeah, it's just for this first time, we are optimizing the tool to make sure that we don't have this delay in loading time. Almost there. Oh my God. Okay. All right. So basically, this is the segmented image. And with this now, we can be able to visualize the cell and classify the cells, morphology, visualize more what's it called? Lineage tree after it has been tested on what's it called? Orlando's tool, which we are still getting into. This is just the part I've not really gotten into. But basically, from the feature I've worked on this tool, this is what we have right now. We can be able to extract the population, or we can be able to extract the morphology, and we can also be able to plot the morphology time series, the graph. So with this now, if I click to classify the cells, we have this. So I can right click and then you can save the images. So basically, you are saving this image to see the classified cell, which one is elongated and other properties, other metrics that we use to calculate the morphology. And then you can click of each cell. And it's pointing us to we're actually still modifying the tool to make sure that it is interactive. As soon as you click on each cell, it highlights the position here, on the image here. And then but then basically the labels are showing are depicting the class for each cell, you know, and the clusters are letting us know which cell are more elongated and which cells are deformed, or which cells are small, or which cells are normal, as you can see here. So yeah, this is just for that. And also you can be able to export the metrics that are used to detect this classification. And all right, so that is under metrics table. So the metrics table is here. We have the area, the perimeter, the other metrics, and then we have the classes. So the idea is when you either click on the cell point, then it highlights on the image, or you can actually click here, any one of them here, any one of the row here, and then it highlights it as well. So basically just for interaction, and then you can be able to visualize better what each cell classifies. All right. So I'm just doing like what's it called? A summary of everything right now. Then we can plot the average pixel intensity for population, and you can see this is what we have here. All right. So this works for both fluorescence, cells with fluorescence and just phase contrast. Uh, that's just a little demo of the tool actually. But we understand the point one and two now, based on the simplification of everything I just mentioned now. And also, like you said, every directory, every new folder must contain the README file, because this is also is also going to help us understand detailed and key information of what your experiment is doing, right? And what exactly you need to analyze. Specifically, you need to give us if you want morphology metrics, if it's population dynamics, or if it is any other thing that is not currently on our tool, and we can, the tool is basically built to keep expanding, right? We can always modify it to suit your purpose. So after this, then it stated here that file must only remain in the designated directories if the initial analysis conducted and it is the analysis has been conducted and the tool has been used on the microcomputer, and if further analysis is performed or is being performed on the server using additional tools. So basically, you must only have it on the folder on the designated folder that you created, if you are still using the ND2 analyzer tool, right, on the microscope computer, and if you are done and you now want to do further analysis on the server computer using the other tools that we don't have on the microscope computer, Orlando 2, Patika, and the other ones, then you can still have it, you can still leave your data sets in the directory. But when you are done with these two processes, you have to delete, you know, you have to migrate it to your external hard drive, or you delete it from the folder. So it is expected that every data set is deleted after analysis are completed. You understand? This is just so that we can have enough space for more experiments or more data sets that can be stored in the computers. So also, once all analyses are fully completed, users, you must be able to transfer your analyzed data to your external hard drive, or you remove them from the folder. So basically, the data evaluation, I already explained that you have to use the ND2 analyzer tool on the microscope computer to evaluate the ND2 files and also to access the experiment results. You can also export it, export the data, everything you got from there. And then everything that you are doing, all your exportation and everything is just going to still be on your designated folder. And also for evaluation and for further analysis, you have to connect to the Mac Studio through the Microsoft computer, and I've shown you the process. So it's just for you to just clickable, and I'm going to do a proper demo for this, a video demo, and as well as attaching pictures to this SOP after this call actually. So it's just a simple click takes you to the server computer. All right. So after this, then we have the data organization on the Mac Studio. So the folders we automatically synchronize. And I showed you now everything that you create on the folder, whether on the Mac Studio or on the Microsoft computer, we automatically synchronize. So basically, if you export some data from Biofilm Q to or Orlando 2, and you export it inside your folder, it will still be synchronized into the Microsoft computer. So we have to make sure that this data we are exporting, they are not so large, and because we have limits to every folder that is assigned to you, right? Every designated folder, we have limits. So, and we'll discuss that here. So we have to make sure that all the data, exported data, and the results, we have to make sure we maintain them to, within the limits that we have for each person, each biologist on the computer. So let's try as much as possible to adhere to these limits and to adhere to this storage management, right? Immediately you are done confirming your analysis, in the tool, in both tools, whether on the Microsoft computer, which is the tool that we are building for you guys, or the further analysis tools. You have to make sure that you remove them or you transfer them to your external computer, external hard drive. And yeah, just so that I can create space for other experiments. So yeah. So there are protocols that we are supposed to follow, basically. And this is not about you, like it's about me and Enrique, the IT guys, actually. So we are supposed to be checking uh maybe monthly or 2 months, we are going to be checking the activities going on the computers, and to make sure that everything is in check and everything is still following the instructions in this SOP, right? So we have to make sure that everybody is following everything that we've said so far. And yeah, so that will be all for this presentation on the SOP documents. Of course, like I said, it's just going to be an interactive session. If you have further questions, if you have anything that you need to understand, or anything that you need to be clear, you can always ask, and I'll be able to answer immediately. I really appreciate you guys for listening right now.
No, thank you for giving this to us, Bukola. This is gonna be helpful. I appreciate it, man. For sure.